Imagine holding a device in the palm of your hand that doesn't just play PC games on the go, but completely dismantles the barrier between desktop horsepower and handheld portability. For years, the portable gaming market was a landscape of compromise. We were told to accept low resolutions, stuttering frame rates, and strip down mobile ports if we wanted to play away from our desks. Then came the first wave of PC handhelds, proving the concept was possible but leaving us strapped to wall chargers, fighting terrible battery life, and wrestling with clunky software. But behind closed doors, a massive structural shift has occurred. ASUS didn't just iterate on their original design, they went back to the drawing board to engineer a handheld that utterly destroys the timeline we thought the industry was on. This isn't a routine refresh. This is the device that repositions mobile PC gaming as a primary platform. Welcome to the definitive reality of the ASUS ROG Ally 2. If you think you know what to expect based on incremental chip upgrades or slightly brighter screens, you are only seeing a fraction of the picture. The real narrative surrounding this device isn't just about running games slightly faster. It is about a radical breakthrough in silicon architecture, a massive leap in power-to-weight thermal engineering, and a direct, calculated war against traditional home consoles and gaming laptops. Today, we are stripping away the marketing fluff to expose the secret supply chain shifts, the leaked engineering data, and the precise mechanical reasons why this machine is forcing gamers to completely rethink their hardware setups. If you want to see exactly where the future of gaming is headed, you need to pay incredibly close attention to the hardware changing the rules right now. The journey to this engineering milestone begins with solving the absolute biggest crisis plaguing handheld gaming: the rooted trade-off between raw computational power and battery consumption. In the past, pushing a mobile chip to deliver desktop-level graphics meant draining the battery in less than an hour, creating an incredibly frustrating user experience. ASUS engineers refused to accept this limitation. The ROG Ally 2 introduces a completely custom, co-engineered processing core built on an ultra-dense, next-generation semiconductor process. This new chip architecture separates light, everyday computing tasks from heavy gaming workloads with extreme efficiency. By utilizing specialized, ultra-low power cores for system navigation and media streaming alongside high-performance graphics clusters, the device achieves a massive jump in battery longevity without sacrificing a single frame of gameplay. But raw processing power means nothing if the device throttles its speed due to trapped heat. This brings us to the brilliant internal thermal layout of the chassis, a masterpiece of spatial management and fluid dynamics. Ditching standard, loud cooling configurations, the device features an advanced zero-gravity thermal system utilizing custom-designed fluid vapor chambers and twin high static pressure fans with whisper-quiet profiles. The system pulls cool air through strategically placed vents on the back panel, forces it directly across the primary thermal zones of the custom silicon, and exhausts it cleanly out the top edge of the frame. The heat dissipation is so incredibly efficient that even during sustained multi-hour gaming sessions running heavy AAA titles, the chassis remains perfectly cool to the touch, and the fans operate at a decibel level that is completely imperceptible to the human ear. This thermal mastery is what allows the machine to extract every ounce of potential from its stunning display. The visual window on the ROG Ally